All right, good morning. Welcome to the session on design patterns in modern JVM languages. My name is Venkat Subramaniam. We're going to talk about patterns, but I'm going to use a couple of different languages here. I'll certainly use Groovy, I'll use Scala, but I'll also use a little bit of Java 8 here. And of course, any information on Java 8 is purely a speculation at this point until it gets finalized. So take that with a grain of salt. Examples may vary. If you attended my session yesterday, there is a little bit of an overlap. So please bear with me when you see similar examples, but certainly Scala and Java would be different than the pattern session. If you attended my Scala session yesterday, there's a little bit of an overlap there as well. Please bear with me on that. But there's enough new material as well in here. Best time to ask a question or make a comment is when you have it. So please don't wait till the end. Anytime is a great time for your questions. And if you do have a question and I'm not responding to you, that usually means that you're not in my line of sight. Just raise your hand or start speaking. That way you will draw my attention. I'll yield to you. And in this room, no matter where I stand, I'm going to hide from somebody here because of the pillars in the middle. So please apologize for that. I apologize that I can't be in one place for everybody to see, but the content is more important than me, so you'll certainly be able to see it. So let's get started. Why should we talk about patterns? That's the first thing I want to talk about. And the reason is, of course, in enterprise development, we often hear about patterns. The Gang of Four book, of course, made a revolution about, 19 years ago. And patterns are very common. But let me start by telling you, first of all, that I really hate patterns. There you go. That was very motivational, wasn't it? To start a talk on patterns. And the reason I say that is because oftentimes we end up looking at what patterns to use, and I think that's a very wrong way to design software. And the reason is you cannot possibly take something as creative as design and come to work and say, let me see what patterns I can put together to make this design work today. Right? That wouldn't work that way. In fact, if you wake up one morning and the first thought that comes to your mind is, I wonder what pattern I can use in the design today, I recommend you call the boss and say you want to call in sick. Because it's no point going to work with that kind of thought in your mind, right? And the reason simply is that it takes a lot more to design good software. Now, let's take an example for a minute. We all know that grandma makes the best pie, right? No arguments about it. And grandma makes the best pie. And you talk to grandma and you talk about this to your friends, and your friends say, well, if grandma makes that great a pie, why don't you get her recipes and make the pie? And so you call grandma and say, Grandma, I want your recipes because I want to make pie for my friends. And grandma says, oh, it's no big deal. You say, no, grandma, tell me your recipe. I want to really make a pie with it. And grandma starts telling you the recipe. You say, tell me slowly. And she says, take some flour and then take some sugar. And you say, wait a minute, don't tell me some sugar. Tell me exactly how much sugar. She says about 2, you say, is it a tablespoon or teaspoon? And you write all of this down, and then you tell grandma, could you please tell me what are the best practices? I really need to know, what is the do's and don'ts, right? And then that weekend, you invite all your friends, in the morning you get up early, and you made the pie. How did it turn out to be? I hear from your laughter, it was a disaster, wasn't it? Last time I tried it, I couldn't get the spoon out, right? I had to run to the store and get the pie. So you go to grandma the weekend and say, you know what, this was a disaster. It just didn't turn out. What did you give me wrong? And grandma says, oh, it's not a big deal. I'll show you how to make it. And she goes into the kitchen and starts making pie. And she takes a teaspoon, measures accurately sugar, and puts it, right? No. She's in the kitchen. She takes some sugar and puts it right there and does that. And you're like, what was that? And you say, that was sugar. How much did you put? Enough? And then you realize that all the measures you asked for makes no sense because people just don't follow recipes that way. Well, the guys who wrote the design patterns book is the grandma and grandpa in our business. And the worst thing they ever did was to write that book. And everybody said, I'm going to read that book and go to work and follow design patterns. Now, the point really I'm making here is we should never design software based on which patterns to use. I want patterns to emerge out of the design, and patterns are a wonderful tool for communication. So when we start designing software, we can say, hey, here's what I want to use, and what are you doing here? Oh, I'm using an abstract factory, or oh, I'm using a strategy here. So it's a really good design tool for communication rather than a design tool for inventing or creating the design itself, in my opinion. Now, having said all of that, it can be a really good communication tool. Let's talk about how we could apply some of the patterns. Now, these patterns have been around for a very long time, even before Java came out. But because Java really leaned so much heavily on object-oriented programming, some of these patterns were kind of lost in time. But we can certainly benefit because Java itself has grown to have the Lambda expressions now. And of course, we have other languages in the JVM that are as powerful. So let's talk about some common patterns and then not so common patterns as well. What I'm going to do here is to talk about iterator. Oh, by the way, I'm going to write quite a bit of code. And the code I'm going to write is available on my website. You can download it anytime you want to. It'll be there for a long time until they remove the website from my fingers, from my access. So you can download it at any time. agiledeveloper.com is the URL. Now, I'm going to talk about some common patterns and not so common patterns. And towards the very end, I will introduce some things we can really do very cool with functional style and function composition, which will be really very nice way to compose applications. So kind of hang in there, and we'll look at some cool things towards the very end. So what am I going to do here? I'm going to talk first about iterators. Now, iterators are extremely common. Let's start with Java for a minute. Now, let's say, for example, in Java, I have a list of numbers. So I'm going to say integer, right? So very common. These may be prices, values, whatever. So let's say numbers equals. And I'm going to simply say arrays.asList. And let's just say this is going to be some numbers, right? A couple of numbers, a few numbers, let's put together. Now, how do I go about to iterate through these collections of data? Well, normally we use a for loop. We say for int I equals 0, I less than, and then we would say numbers.size, and there's a mandatory pause right there to think, is it less than or equal to, right? All of us have gone through that, right? There's a name for that kind of pattern. It's called self-inflicted wound pattern, right? Because every time we use this pattern, we really suffer through it. I don't know, it may be even illegal to use this for loop in some states. You may want to check your local state law, that's how old that is and really archaic. Well, at least what we can do in Java is we could use a for each statement. So we could say number, of course, we use a colon for that. And we could say numbers, and then we could start printing the values out as a number. For example, in Java, we would do something like this. So we could run through the Java code and get the output. As you can see, it prints these values. But I'm going to take a shorter route here. I'm going to just print these values just like that. And I'm going to simply say output, and we'll say numbers, and just print it out. So that's the numbers as a collection. But the real interesting part is we not only want to iterate through this like this. Imagine the job given to you is to double each of these values. How many of you have taken some values in a collection and done some stuff with it in this room? Almost everybody, of course, right? We all remember that. So let's try this again. So I'm going to say a list of integer doubled equals. And what do we do now? New array list of integer, right? So we create an array list first of all. Empty one, of course, right? So we create an empty collection. What is the next thing we do? For, and we say int number in numbers. And then we say the doubled value dot add number times 2 in order to double it. And when we are done with this whole thing, we can print out the doubled values out right there. So look at the code we wrote to do just that. We first created an empty collection, and then we iterated through one element at a time and doubled each of the elements and added to the collection, and then we printed it out. How do you feel after writing that code? Dirty. That's right. If you go home that evening, you're tired already, and the kids run over to you and say, don't touch me, I have to shower first, right? That's how dirty you feel about it, right? There is a name for this pattern. It's called primitive obsession. And Java programmers have a lot of that. We all share that, right? But do we have to really go through that length to do something simple? Because notice what we did. We told every step of the way what the program should do. That is extremely low level, isn't it? So we don't have to do this, fortunately, anymore. We could simply say output numbers.map. So we call a map function right there. And to this map function, we simply say, given an element E, return to me E times 2, and that is basically simple mapping that we are trying to do, and that is Java 8 syntax, right? So Java 8 allows us to do lambda expressions, and it'll fundamentally change the way we write code from now on. So what we are saying here is we are saying, given the numbers, I'm not interested in iterating through one element at a time. I want to apply a mapping function. So basically we said map this, and given an element E, apply the transformation of E times 2. But the beauty of this is the given value is immutable as well, and as a result we get a new collection without touching the original collection given to us. So not only is it more concise and more expressive, this is much safer as well. Like what? It is easy to decide how to iterate through this, but I'll kind of keep you on the bay for that until the very last example where we will look at the benefit of that towards the very end of this session. So we can do this pretty nicely here in Java, but let's go a little bit further to Groovy for a minute. So I'm going to say val over here, Groovy, define nums, let's say, equals, and I'm going to create a bunch of numbers, same thing as we did on the other side, but I want to loop through these numbers. How do I do that? Here is Groovy, and I simply say print it. And it's able to print through these values and say, here are the values in this collection. You can see that it printed it, right? But I want to be able to map through these, and here is, again, the Groovy collection. I say collect, and I'm going to say it times 2 for this collection, and you can see how that's able to respond to the collection here, and we can see that it's printing the value twice of it. So it looks very similar to what we did, collect rather. So it did something very similar to what we did in the case of Java, except that we didn't have to say element, but if you do, you could simply say E arrow, and then you can say E times, and you can say the same thing in Groovy as well. So you can see how the Java syntax looks very similar to the Groovy syntax in this case, almost similar. If you want to find an element, let's say I want to find the first element, which is a double value, even value, how would we do that? We could say nums.find, and I'm going to say it is even. So this is a check to see if the value is divisible by 2, and I'm asking him to give me that result, and we can see that it tells us the first value that is even. Or we could say find me all the values, and you can see that it gives us all the values. But one of the interesting things about functional style of programming is not just this higher order functions where we can pass functions to functions, but also it's about immutability. Now you say, how do you really deal with immutability? What if I want to find the total of all these numbers? Here is an imperative way of doing it, right? We would say total equals 0 to begin with, and then I would say, for example, print the value of total when you are done. And in this case, I would say, given a number n, which is in nums, go ahead and add it to the total. So total plus equals the value of n itself, and we could add it. Now this is an imperative style. We are used to this style of programming. We could do this readily in Java. But if you ask me, how do you do this immutable? It would kind of puzzle you, right? How would you possibly total things without changing anything? Well, let's take a little experiment how we could do that. Imagine I want to total everybody's age in this room. I want to know the collective Java experience we have in this room, right? And I'm going to start with this gentleman over here. He's not smiling anymore because he's worried I'm going to ask for his age. No, you look pretty young as well. You don't have anything to worry about it. So how would we go about doing this, right? So I'm going to take a little paper, put a 0 on it. That's the age of everybody to his left right now. And I give the value of 0 to him. And he's going to total his own age. But remember, we are talking about immutability. He cannot modify this post-it note I give to him, right? So he takes his age, adds to 0, but what does he do now? What can he do? Any options? Create a new post-it note, right? And he creates a new post-it note and forwards to the person next to him. And what does he do? He takes the post-it note from the person next to him, adds his own age to it, creates a new post-it note, and forwards it. Notice how we're not mutating any post-it notes here, but in the end, of course, the value I get from the last person in this room would be either the age of everybody in this room totaled or an integer overflow exception. No, just kidding. So basically, we'll get this value computed, right? How would we do this in Groovy code, by the way? Notice what we're going to do here. I'm going to simply say, in this case, a print line nums.inject. And we start with the 0 value to begin with, because this is the seed value I gave him, the value of 0. And this is going to be a carryover and an element as a parameter to begin with. And all that I want to return from here in this code is a value of the carryover plus the element to find the total of all the values in this collection. So again, we are using a higher order function, and this is a different form of iterator. So we already saw a couple of different iterators here, right? We saw the each method, we saw the collect method or the map method, we saw the find and find all. Each one of them is an iterator, but with a different flavor, and each of them are called the internal iterators that we can very effectively use. So you can see how easy it is to work with these collections of values and nicely put things together in the code, right? So that is an example of how we could use iterators. You can do similar things in Scala as well, but I won't show that here because it's going to be very similar to this. I'm going to show you yet another pattern we can use here, which is called a cascade pattern. Let's take an example of this in Java first of all, but I'm going to write this in Groovy, but it should be very easy to see how this is going to look like in Java. Let's say we have a mailer class to begin with, and my mailer has some functions, maybe public void 2, which takes an address as a parameter. I'm being verbose here just to show this is a Java code. And I'm going to say system.out.println, and maybe all that I want to print here is 2, so we can see that it's being called right there. So similarly, I'm going to write a method for from and then subject and the mail body and then the send itself. So this is going to be the from method, this is going to be the subject method, and this is going to be the body method, and finally I'm going to send it. I'll simply say sending over here. So this is going to be taking the from address, this is going to be the subject, I'll say sub, and this is going to be the subject it's going to take, we'll say subject. And here is a body that I'm going to send to this, and that could be a message I'm calling into this. And finally, here's the send method, which doesn't take any arguments at all, right? So that's a simple Java code. Now, how do I use this Java code? Mailer equals new mailer, right? That's the way we create an object of this particular mailer class. And then we would say mailer.to, and this could be an email from to me, so it could be my email address. And I could say mailer.from, and it could be maybe an email from my build machine, so build@agiledeveloper.com. And then it may be a mailer.subject, right? And some subject it's going to send to me. And then mailer.body, it's going to be an email body content for it. So finally, of course, I would say mailer.send, right? Now, if we run this code, this is purely a Java style code, no difference here, right? So we're going to send this from here, and this is going to be the sub method. There we go. And you can see that it's running. But look at the code for a second. Anybody here who has written this style of code before? Of course, everybody in this room. How do you feel about this? Dirty again, right? Actually, it's worse than that. Those of us who work from home, this is even worse. If you're working at home and a kid walks in, immediately you close your monitor, right? Because when kids see this, they look at you and say, that's what you do for a living, right? And they never want to take after a profession, right? This is really hard, right? So absolutely, this is tough. Now, what is wrong with this code? Well, where do we start? The first problem with this code is, look at the duplication we have in this code, right? Redundancy, mailer, 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 mailer. If you do this to a human being, they'll strangle us, right? That's how redundant this is. The second problem in this code is, look at what's happening at the very end. We call the send method, and now we say, do I reuse this mailer object or not? What's your answer? Don't know. And then you say, go read the documentation. Right? How do you read the documentation, right? Documentations don't give us anything these days, right? I mean, honestly, the other day I was reading a function. The function name is called pass-through. And honestly, I didn't understand what pass-through means. So I went to the documentation, and the documentation was very helpful. It said, this function allows you to pass through. Okay, that's excellent, right? Very helpful. So how do we deal with this kind of function, right? So here's an idea. Even in Java, we can use this. This is called a cascade method pattern. And I'm sure you have seen this pattern in tools like Juice or EasyMock and various other tools. I'm sure you've seen this. And this cascade method pattern, by the way, another favorite name for, well, I'll come back to that. So basically what I'm going to do here in this pattern is, to the very end of this function, I'm going to simply say return this. and every function returns the current object, the context object, right? And so they're returning this object at the very end. So now what I can do in here is simply remove all these semicolons at the very end of these. So those are gone. I will remove this mailer here, and I will remove this noise from here as well, so they can all kind of tag along and execute this through. So this is going to be all these functions. I'm going to lower the font so I can actually see what I typed. So in this case, I have the return this in each of these functions right there. And then finally, at the very end of this function, I created a mailer. I create a to and a from, a subject and a body, and then I close it with the call to the send method itself. Now, what's happening in this case? Let's see why he's giving us an error in this case. Anybody sees the problem? Oh, of course, the void methods, of course. So I'm so used to working in dynamic typing that I don't care to give the type, but let's put mailer here. That should make the compiler happy, right? There you go. So we are able to return that. So this is called a cascade method pattern. But if you want to use a different name for this pattern, there's a very friendly name for this pattern. It's called the train wreck pattern, right? Because you kind of wreck it like connecting these things together. And of course, you can get very creative with this pattern. Along the way, rather than returning the this itself, you can morph the object you create. And as a result, you may receive an object of one kind to this function, but create another type of object. And then it can flow through a nice interface, and you can tighten it with the interface functions. So there's quite a few interesting things we can do with this pattern itself. But let's say we don't want to do that. We don't want that. We want a little bit more fluency. Now we can get a little bit more fluency, but what I'm going to show you here, unfortunately, is going to work in Groovy, but it's not going to work in Java, at least not yet. And the reason is we're going to use two things together. We're going to use the lambda expressions, but we're also going to use a Groovy magic here. And the Groovy magic is a concept of delegates that it has. So let me show you what you can do with this. The first thing I'm going to do here is to make the send method static over here. So notice the send method is static, and as a result in this method, I'm going to create an object of mailer right here. So I say mailer equals new mailer, created an object of mailer, and then I'm going to say in here block dot, and I'm going to send the mailer to the block, where the block is a closure I'm going to receive as a parameter. So notice what we are doing here. Rather than calling a function on this object, we're going to send a function to this function, and that function is going to be this block function, lambda expression. Up to this part we can do in Java 8 as well. We create a mailer object, we pass the mailer to this block, and then when it comes back, we're going to do the sending operation. How does this help? The beauty of this approach is we no longer have to be calling the new on this object anymore. So we're going to simply say mailer.send at this point, and we're going to get a mailer object on our hand, and then I'm going to grab all this part and then move this right here, and we could remove some of these noise from here as well, and then we could just call this directly from here. So we can see how that's working. As you can see, we removed quite a few interesting things. The first problem we addressed here is it's very clear what happens after the send. After the send is over, the object doesn't exist on our hand anymore, right? So as a result, when we get out of this, the mailer is gone, poof, we don't have to worry about it, right? That's one of the advantages. But you say, wait a minute, but that's great, but this noise is still there, right? And how do we get rid of the noise? So let's get rid of the mailer from here and run this, and that doesn't work really, does it? No. Well, what do? It turns out that Groovy closures have a special property. If you call something on it that it doesn't understand, rather than complaining to you like it just did, it will just take one more opportunity to say, let me check with the delegate. And if you have a delegate assigned on this object, it will check with the delegate and say, hey, do you really have this method? If so, I would like for you to handle it. So notice what I'm going to do here. I'm going to go back to this code and say block.delegate over here equals mailer. And now I no longer have to send the mailer to this function. And when I execute this, you can see that in this case, it works like a charm. Now, basically the idea is that when you attach a delegate to this object, it will take all these unhandled methods and route to the delegate and say, could you please handle it? Now, without going into details, unfortunately, I don't have time to dig into these details, but you look at this code and say, that is 2 lines of calls you had to make That is not Groovy, right? Because in Groovy, we should do everything in one line of code, right? You know that. So absolutely, we can do that. So we can simply remove that code and say, simply mailer.with block, and that's good enough for it to handle it. There's a few more details about it, but unfortunately, I won't be able to go into those details right now. But look at the beauty of this. It leads us to something fairly lightweight, kind of like a DSL kind of a call, if you will. And you can even go to the extent of making all of these guys single code to make it really lightweight if you want to. So if you do this really, right, notice what happened in this case. You can notice that how lightweight this really is. And if you run it, it works. But here's the beauty, right? If you go to somebody and show them this particular block and say, what does it look like? What are the chances they're going to look like that looks like Groovy code, right? Only if they are Groovy programmers. So this looks like more like a configuration data. So data becomes code and code becomes data. It becomes very easy to create DSLs or domain-specific languages very easily in this language. And that's exactly what we did using Lambda expressions and Groovy fluency together. The next pattern I want to show you is one of my favorite patterns. It is called the execute around method pattern. And I'm going to use Scala here to show you this example. Well, actually, let me show you this example in Java first. So let's say for a minute that you are working with a class that is expensive. So class resource, and this class resource is expensive class. So public resource, and we will say here output create expensive object. All right, great. Now I have a function called public void, and let's call it as op1, and all this is going to do is simply say op1 over here. So we know that we are calling operation 1. Similarly, I have an operation 2 that I'm going to use here, and that's going to simply say operation 2. And of course, this is an expensive object. Imagine for a minute that I write a finalize method. What do you think of the idea? Finalize method, yay, great, go for it, or boo, don't do it. Boo, don't do it. This reminds me of an experience. One of my clients called me up one day and said, we got a problem with our code. While you do code review, maybe you can help us find it. And I asked the boss, what's the problem? He said, go talk to the programmers. They will explain to you what the problem is. I went asking programmers, and one programmer explained it the best. And he said, our application works fine most of the time. I said, that's great. Tell me when it doesn't work. He said it doesn't work between 7:15 and 9 in the morning. I'm like, damn, that's awesome. You're predictable every day. He said, no, only Monday through Friday, right? It works fine Saturday and Sunday. So I was kind of puzzled. What would happen Monday through Friday? Well, it was a large company with 100,000 people working for them. You can imagine, right? People come to work around this time. And of course, this was a portal application. As I started looking through the code, I realized that these guys were creating a database connection in their object. And in the finalize method, they were releasing it. And of course, the JVM said, look, I have a lot of memory. I don't have to release these objects. So as the code was running, it would create these connections that would never release. Of course, the exceptions were not being handled properly. And as a result, things kind of ended up failing. Once I understood this was the problem, I wanted to make sure this really is a problem. So what I did is simply went in and put a little method called close. And in the close method, I did the cleanup, right? So I just said cleanup, right? So this is where I release the connection, what have you. And to make sure this is actually working, all that I had to do was this. So resource, basically, let's say start with the resource object I want to create. So resource basically here, so let's call it resource equals new resource. And then, of course, resource.op1 was called, resource.op2 was called. And this is kind of like the code they had in the beginning, right? And all I did was to make sure this is being cleaned up properly, I called the close method. And of course, once I called the close method, the problem was gone, poof. And they were kind of doing a little profiling, and they said, wow, look at that, the problem is really gone. But the real fun was that afternoon. The boss comes back and says, how is it going? And the team said, well, we fixed the problem. So he was obviously very excited to hear this. He said, what did you guys do? And the team said, well, Venkat asked us to add that one line of code, and it fixed the problem. And then there was a little pause, and then he said, what else did you do? Well, that's it. And then I heard them say, do we still need to pay him? Right? So, okay, fine. We could have this little, call to this close method, great. But this logic is still flawed. What's wrong with this? Say that again for me. Exception handling, right? What if operation 1 or operation 2 threw an exception? We're in trouble. Oh, here's an idea. Let's put a try block, and then within the try block we will do this, and then in the finally block we'll clean it up. So we have to write code like this. What do you think? Too much work. And this requires discipline. And if you ask me to do this, I'll forget this most of the time, right? And then you come back and say, programmers should have discipline. You got to know how to write code. And then we'll write this in effective Java, right? I mean, why force me to do stuff? If this is the right way to do, why don't you make it easy for me to do it the right way? Well, Java 7 has a wonderful feature called ARM. Remember that? Automatic Resource Management. Anybody aware of that? Yes. So moral of the story, never trust a feature with the word management in it, right? Why? The reason is, the way you would do this is, you would say, try, and you would say resource. You would put that resource right here in this call. And you would then have to say, all right, here's the try block. And then I'm going to say, call this within here. But the nice thing is you don't have to call the finally method. Of course, if you run this, it's going to complain to you because it doesn't have a clue what close method is. And close will be called automatically here. So it says for this to work, you have to implement an interface called auto-closable. I mean, that's Java way of doing things, right? For everything we have to solve, we'll have another interface to solve it. So right there is auto-closable interface. Now, why don't I like this? Am I just a grumpy old man who doesn't like this? Well, partly that, but the problem really is that the try still requires us to put a try block. If I don't put a try block, we are back to square one. In fact, this is exactly what .NET did back in 2001 with the using statement, and I hate the using in .NET as well. And so this is no different from that. So what is it that I'm really trying to get to? What I'm saying is, if this resource is really that critical, if we have to release it right away, let's make that happen by design so the programmer doesn't have to know this. Go ahead, please.
So the point you're making is that it's still the programmers, the application programmers are worried with it.
Absolutely. I have to still remember to do this, otherwise we're back to square one. And then you have a bug in the code and you got to fix it, and that becomes a problem. And we also use this for another purpose. I'll talk about what that purpose is a little later. But notice what I'm going to do. This is Java 8, by the way. And you can do this in Java 8. And I would not definitely use ARM anymore in Java when Java 8 comes out. So notice what I'm going to do. I'm going to make a, first of all, I'm going to make the constructor private. Isn't that awesome? And I'm going to make the close method private. So now the programmer says, man, how do I use this resource? I can create it, I cannot close it, right? Yeah, now we got them thinking. Now I say public static void use. And I'm going to provide a use method. And this use method says use resource as an interface I'm going to send to it. And I'm going to say block. Let's see where this is going to go in just a second. What is this use resource? And I'm going to write an interface here. So interface called use resource, assuming I type interface correctly. Interface called use resource. And this only has one method called apply, which takes a resource as a parameter. Let's call it resource, right? Just hang in there with that interface right there for us. So I write a use resource method. But how am I going to use this really? Well, you see, I can no longer create a resource like any of these. So what I'm going to do instead is simply say resource.use, and I'm going to provide a block of code for it. And that block of code says, I'm going to take a lambda expression here, and I'm going to simply not do a whole lot within this lambda expression. Let's start with this for a second, right? So that is all I'm starting with. Maybe it needs a little bit of something here. Let's say, 2, return 2 or whatever, right? So basically, I have a little lambda expression in this case. Now, how is this going to help us really? The point really here is that the use resource is an interface. I'm going to call the use method, and I can no longer call the resource and the close. And of course, I don't need this auto-closable method anymore. All that is gone from us, right? Excellent. So how would I go about to use this method now? Method use in the class, resource cannot be applied to given type. Not sure why it's complaining that, but we'll figure out. So now what I want to do here is simply say, within this block of code, I've got a resource on my hand. I'll say resource.op1 here and resource.op2 here. But the beauty is this. I enter a block of code right there, the lambda expression, and when I enter this, the resource has been created and hand delivered to me. And when I leave this block of code, I return control back to the use method, and the use method can clean this up for us so we don't have to do this manually. And so there's an automatic instantaneous garbage collection that can happen for us right at the moment. But how would this really be possible? So what I'm going to do here is to create a resource object, we'll call it resource, equals new resource. But I can remember to do this once, right? I can, as an author of the class, write a try block. I can write a finally block, and then within the finally block, I'll do the close method. Remember, this is the author of the class, not the user of the object. And then within this, I'm going to yield control, and I'm going to say the block is going to receive, the apply method is going to receive the resource given to it. So the point really is that if somebody wants to use this, they call the use method, and then the use method is receiving a block of code. Before we enter the block of code, we create this object. We yield the control to the block. The block does whatever it wants to do. When we come out of the block, we'll do the cleanup and go home. This is called the execute around method pattern because around this code, you're doing your pre and post operations. Sometimes people call this as a loan pattern as well because it's kind of like renting a car. Before I rented the car, they clean it up and give it to me. When I return it, they check for damages and accept it, right? So it's kind of like that. You have a little loan pattern going on here as well. Let's make sure this is running before we continue further with this. So I have the try and finally block. What am I doing wrong here? So we'll call it as use resource. Use is the method, the public static void. And I've got the method here. So I've got those two private. And I have the resource over here. So let's see if we can able to find the error. Let's see what the error tells us actually. Okay, fine. So you can see how the cleanup happened. And notice in this case, whatever we do here, right, just to show that it's working, yield control. So let's say output, yield control, right? So we are yielding the control to this particular closure given to us, a block given to us. So we yield the control right there. We did the operation. What you do in your block of code is entirely up to you. Let me tell you where we use this. This is really good for resource cleanup, certainly, but that's not the only purpose of this. I was working on a project where we had a service tier, and in a service tier, we had to do transactioning. And I noticed very quickly, all the service tier classes had the same boilerplate code where we'll create a transaction, do some stuff with it, and clean it up after that. And I got really annoyed with this because it's copy and paste of the code and then changing it. So what we did quickly was we created a class called transaction class. And then we wrote ourselves a method called run in the context of transaction, which would return a transaction object in the block of code. And so all that we had to do now was in our code say transaction.run in the context of transaction. We receive a transaction object, write our code, and then when we leave the block of code, the method would then in the finally block would smell the transaction and find out if there was an error. If there was an error, it will roll back the transaction, otherwise it would commit it. So we then had to really simply use that method, and we didn't have to create transactions anymore. But look at the beauty of this approach. This is a first step towards a benefit, but imagine you are interested in unit testing this code, and you don't want a real transaction, a real database. It becomes trivial because the function that calls this can give you a transaction in a completely different context, right? It could be a database transaction, a remote transaction, or a mocked transaction, what have you. So this really takes you to the next level of dependency injection and inversion, and that's in the right direction. So those are some of the benefits of using this approach. As you can see, that's one of my really favorite patterns. Now, I said how you could do this for some of the two approaches. One is to resource cleanup. I also showed you how you could do this for really performing this transactioning. But let me kind of deviate from this example and talk about something else. Oh, by the way, you could do this in Scala as well. And the concept is really the same, except it's going to be a lot more cooler to do that in Scala, that's all, right? So I'm not going to show that to you right now. All right, so let's talk about where else we can use. You probably have used JUnit test cases, right? So let's say for a minute, we have a test called void test something. And in the test something, I'm going to do this. I'm going to say, object.some method, I'm going to call some method. and I got a bunch of code here. Then I say try, and I say catch, and I say some exception, EX, and then I'm going to say here, usually I like to put a smiley here to say that I'm expecting an exception. And then within here, I'll say object dot some, do something, so do something. And I want this do something to throw an exception on me. So I'm going to say fail expected exception for whatever reason it is. Sounds familiar, right? So this is called an exception test. Now, of course, you probably have written test cases like this, and you realize, gosh, this is so boring to write in this verbose manner. And when JUnit 4 came, we were excited. Because in JUnit 4, you don't have to do all of that, right? So you could simply say test, and then you could say expected exception equals some exception dot class, and then you could say public, something like this, right? Void, and you could say void test something. And then within this method, you could simply say object.some method, and then you could write all these methods you want to call, and then you could simply say object.do something, and that was really cool, isn't it? I hate this approach. And I refuse to use this. And the reason why I hate this is because this is an example of a code that is not concise. It's an example of a code that is terse. There's a difference between being concise and being terse. A concise code is helping us. A terse code is hiding to stab us, right? And that's what this code is doing, right? And why is this such a bad idea? And the reason is, I want my unit test to pass for only one reason, and that is the code is doing exactly what it's supposed to do. Notice the reasons for which this test is going to pass. This test will pass if do something throws some exception. Absolutely, that's great. But unfortunately, this test will also pass if any of the code in the test, including do some method and any other method that follows, any of those throws an exception, this test will incorrectly pass. And I'm not happy with that, right? Because I don't want my test to ever pass for the wrong reason. So what do we do about this? The beauty is we can use lambda expressions and use the execute around method pattern to solve this problem. Let me show you how you could do this in Scala and Groovy today, and hopefully you can do this in Java 8 as well when Java 8 comes out with lambda expressions. So the way you would write this in Groovy is you would say public void test do something, right? So test something, and in this method you would simply say object dot some method. You would call these methods like you normally do, whatever those methods are. But then in the very end, you would say should fail or something like that, right? And when you say should fail, you would simply say what exception you expect, so some exception, and then you would put the block of code object.do something, and notice how we contained that to that one line of call. So it is going to call this lambda expression, evaluate it. If that lambda expression threw that exception called some exception, this test will pass. If that lambda expression doesn't throw the exception, this test will fail. So it really narrows it down. That's an example of being concise without being terse. And again, we are using the pattern called the execute around method pattern here, but essentially for a very different purpose. So that's one of the reasons why I think this is my favorite pattern, is this pattern can be used in so many different ways nicely to formulate our objectives in code and get to a very concise code as well. So we looked at quite a few interesting patterns. The next two I'm going to show you are pretty interesting in terms of pulling in stuff and mixing them together. In the case of Groovy, mixins are runtime. In the case of Scala, traits are compile time. And there's going to be a little bit of redundancy in this example. I apologize for that. For those who attended my Scala talk yesterday, you've seen most of this already. But for others, this will be new. So I apologize. Bear with me when I go through this. So in terms of the functional composition, that will be relatively new. I haven't spoken about that here. So we'll get to that. So what is a mixin and what is a trait and what can we use that for? I want you to think about a design problem just for a few minutes. And when we finish this, I'll come and show you how to do this in Scala for a minute, in Groovy rather, afterwards. So let's switch to Scala and look at an example here. So let's say a class called human, and I have a class called human, and this class human has a method called listen, and the listen method simply prints out a print line basically in this case, I'm just going to print out I'm, and then I'm going to print the name, and then I'm going to simply say listening, right? So this is going to be simply printing this message called I'm listening, and I'm going to try this out. So let's go ahead and create an object. So Sam equals new human, and then I'm going to say sam.listen and call that method here. Of course, I need to provide what the name is. It's going to fail because of that. But let's go ahead and fix that real quick. There we go. So let's say val name is, well, actually, we can give it up here. So let's say val name is going to be a string. So I can give a name for this object as I'm creating it and then call the listen method. Now, this is not something really unusual, right? We start modeling applications and very quickly realize you put a listen method in the human class. What does listen got to do with the human, right? Who listens, by the way? Yeah, well, he says he does. Well, we have to check with the other better half of viewers to know if you're really listening, right? We all have selective listening. Well, I'll tell you who listens. A friend listens to us. I mean, that's what we rely on friends for, right? When you're really down, you want to go to your friends and say, you know what? My job sucks. And your friend says, tell me how it sucks. How can I listen to you? You say, well, it's not my job that sucks. It's my boss that sucks. And what does a good friend say? Tell me, how does your boss suck? Not so good friend says, maybe you suck, not your boss, right? So that's how we know who's your real friend. But there's another friend we cannot ignore. Who is that friend? Somebody who listens to you but never talks back to you. Dogs are awesome friends. Now we got a very hard predicament on our hand. Imagine you're in Java for a minute. In this wonderful world of Java, you create a class called human, and it has a listen method. And your requirements change on you. Now you realize you got to model a dog which can listen too. Here's one option I can think of very quickly. Inherit dog from human. No, dogs don't like it. What would be your Java way of solving this problem? Oh, a friendable interface. That's correct. So we create a friendable interface. What's the next thing we would do? Inherit human from friend and inherit dog from friendable, right? We'll inherit from those two classes from that interface. Then we scratch our head. But wait a minute, where do I put the listen method? It's a common method. Hey, put that in the interface. Interfaces cannot have implementation, right? Why? Interfaces don't do anything, kind of like my boss, right? It promises you a lot but never delivers anything, right? So you need to really implement this in a concrete class. But how do we do that? Hey, here's an idea. We'll create an interface called friendable. We'll create a class called human, create a class called dog. They both inherit from friendable. Then we'll create a separate class called friendable abstract class, which will have the interface method. And then from the human class, we'll call into it. From the dog class, we'll call into it. Make sense? Well, if that's what we're going to do, why do we have to do that? Why can't the language do that for us? That's exactly what Java does. Scala does. So in Scala, traits are nothing but interfaces. So how I'm going to use it is, I'm going to simply say in this case that I'm going to create a trait called friend. So I'm going to say trait called friend. And the friend is going to simply have a listen method. And within the listen method, I'm going to simply go ahead and call this particular class. So it's going to have a name, so val name, and I'm going to simply say this is going to be a string, and of course it's not implemented. Then in the human class, I can simply extend this over here and say extends friend, right? So I could do this. Now what I can do is simply create the human and call the listen method on it. But look at the beauty of this. We could create a class called animal, and the animal can have a name, of course. So we could say name, and that's going to be a value as well. So let's make it a string. And now I can then create a class called dog, and the dog class can say, there we go. Dog class says extends from, so override the value name, so name, which is a string, and this is going to extend from animal, right? So this is going to be the name that I'm going to send to it. But I'll say with friend, and I can mix in the trait at compile time. So we could say buddy equals new dog, and I'm going to create a buddy dog, and I can say buddy dot over here, listen, and call the listen method on this particular dog object, right? So how does this really work in this particular case? So override value name which is what I want to create here, value override name. So I think it's the other way around, but let's figure out what the problem here is. Oh, what did I do? Oh, what a picky audience. Fine. So thank you. So right there, it's able to run through that, right? So notice how we didn't go through redundancy. We nicely wrote an interface, sorry, a trait, and Scala quietly created an interface for us, an anonymous inner class, sorry, an abstract class for us, and then mixed those two in. It did everything we would be doing otherwise. Now let's extend this example one more time. Class cat, and cat is going to extend from animal as well. And this is the beauty in Scala, is now I have a cat class. So I say val alf equals new cat and create a cat object. We'll call it alf. And I want to go ahead and call alf.listen. Will that work? No. That's because cats are not friends, right? Cats are evil. But you say, but my cat is really friendly. Well, fine. What you could do is, don't mess with alf. It's a lost cause. But your cat, right? Your cat can say equals new cat. Let's say this is Oscar here. And Oscar says your cat dot, and then we could say listen. But right on this instance, we can mix in a friend. So only instance level mix in rather than class level mix-ins. You could do very similar thing in Groovy as well using a mix-in by simply creating the object and doing a mix-in and then add that. So I won't go into that detail right now. Now, unfortunately though, because I have 8 minutes, I'm going to skip this decorator but get to the real functional composition because that's something that I didn't cover so far and it'll be really fun to see how that's going to change the way we do things. So you can do this in Java as well when Java 8 comes out, so there's really good hope for us. So let's look at an example here. I want to first of all make sure my internet connection is up. So let's make sure, because I want to connect to the internet to do this. Seems like it. Let's do this. So tickers. So I'm going to bring up a bunch of ticker symbols. So I want to go out to the web and look for some ticker symbols and values that I want to connect to. So I got a bunch of ticker symbols, just a value, set of values, right? It's a value that I've created right here. That's what I was missing, the double quote right there. There we go. So now that I create these tickers, I want to go out to Yahoo and ask for stock prices. So get price from Yahoo. As you can see, I write code really fast. So right there is a code to go to Yahoo and get the price. Not a big deal. But my problem on my hand is this. I want to get the highest stock priced ticker less than $500. That's my problem, right? So I got two functions I need. Define is less than 500. And what is this going to do? Notice I have a stock price class on my hand. So this is going to simply take a stock price as a parameter and simply returns stock price dot price is less than 500, right? So that is all I'm returning, right? So stock price is less than 500. That's my is less than 500. Make sense? So one more function, pick high. And pick high takes two stock prices, stock price 1 and stock price 2, right? And very simple again. And what does this guy do? He simply says, if stock price 1 dot price is greater than stock price 2 dot price, return stock price 1, else return stock price 2. Because if it's an expression in Scala, we could do this. So I'm done with all my preparatory work. This is simply to get me the highest stock price. Now think about this, the Java way of doing this. How would we make this work? Well, our first step, we got to go to Yahoo and get all the prices for the stocks, isn't it? See if this makes sense. The first step is variable tickers and the prices equals. So this is going to be a list of stock prices. And this is going to be an empty list. Am I making sense? Like the map example I did a long time ago, right? What appeared to be 40 minutes ago. And then what am I going to do? For a ticker in tickers, you can relate this to the Java syntax. And what am I going to do here? Tickers and price equals. And I'm going to say get price from Yahoo for the given ticker. And I'm going to add it to the tickers and prices. So what have I done so far? All that I did so far is to go to Yahoo and get all the ticker prices for all the stock prices for all the tickers I have. Let's make sure this is working first before we go any further. So I'm going to run this code. And it's going to go out to Yahoo and get the stock price for all the tickers I have. This takes anywhere from 20 seconds to 3 days normally to run. And we'll get the prices really quickly. Make sense so far? Notice how step by step we are moving, right? What's the next thing I'm going to do? Okay, now that I have all the stock prices on my hand, I got to only select those that are less than $500, right? So right there we got the prices. What's the next step? Get all the prices less than $500. How do I do that? Var tickers less than 500 equals, so this is another list on our hand, right? Stock price equals to an empty list. For stock price in tickers and prices, right? Tickers and prices. And I'm going to simply say in here, if is less than 500 stock price, go ahead and add this to tickers less than 500 equals. And this is going to be stock price on our hand plus the tickers less than 500. So this should give us only tickers that are less than 500. Making sense? Very simple loop, right? Nothing complex. The syntax is different, but it's a traditional for loop. Our last call, what is it? Var high priced equals stock info empty comma 0.0. That's our initial value that I start with. Then I say for stock price in tickers less than 500, high priced equals pick high, high priced, and stock price. When we are done with this whole thing, print high priced out because that's our highest price stock less than 500. Make sense? Well, before I run this, let's do one more thing. Let's go up here to the get price method just for the fun, and I'm going to print out getting price for, and we will say ticker. So we can kind of see this actually happening. So let's go run this little code. It should go out and get a stock price for each one of these guys and report it as it's running. It should report it, right? So right there it went and got all the prices. It reported right in the end that the Oracle was, hey, what a chance. Oracle is the high price right here. So I want to open up a command prompt here so we can actually see this run. So bear with me here. So Scala, there we go. So what I'm going to do is simply run this on the command prompt so we can actually see it. Scala, and then I say sample.scala. So you can see that it's sending one request at a time, right? Right there. Make sense? One request at a time, awesome. Let it work, we don't have to wait for it. But look at the code we wrote. This is primitive obsession, isn't it? We first said, go get me the stock price for all the tickers. Then pick the ones that are less than 500. Then, by the way, pick the highest price, right? By the time we are halfway through it, it's lunchtime, right? That's too much work. Comment all that out. Look at the code I'm commenting out. I'm commenting all that code out. So far, so good? Let's do this one more time, can we? Tickers, what do I want to do? Go out and get the price for each of the tickers. Map, get price. Happy? Okay. Filter is less than 500. Reduce it down to what? Pick high. And when you are done, print it. So we've simply said, go out, get all these prices. When you're done, go print it. Let's run this here one more time. Again, it's going through one price at a time, as you can see, right? But what's happening in this case, though? It is saying, I'm going to go run through, but I'm going to filter through. What's happening in this case? It's still Oracle. Good news. The market is still open. It better be the same result. But what did we do? Tickers go get all the stock prices. So we started with an array of ticker symbols, and now we have an array of tickers and prices. Then we narrow it down, filter, and then we said is less than 500. From those values, reduce it down. With me so far? What is the big deal? The big deal is it's concise. The big deal is it is less work. And the big deal is, look at this. I copy this one more time, and I go back to this guy and say, hey, I am going to Yahoo and getting all the prices. That's my first step. I'm doing a little math here. And then I'm doing a little bit more math here. So there is one request to the web and two math. With all respect, what is slow here? going to Yahoo, unless you are a 1984 processor, right? I'm making sense? Going to Yahoo is the slowest link here, isn't it? Yeah. Well, if we can take that and make it parallelized, that would be so cool. And you're sitting at work and they're saying, make this parallel, and you're like, oh no, I don't want to make this parallel. What amount of change I have to make for that? Dot par. There you go, done. So notice this for a minute. We sent requests one at a time. I'm going to hit the return. Notice what happens. For all the requests, Yahoo is waiting to send the response back, right? So you can see how it was trivial to parallelize that code because we had used lambda expressions and because we made them pure. So less code means it's easy to maintain, easy to modify, less clutter, less noise. It gives us the power. And the beauty is this, right? These kinds of techniques gives power to us, the programmer, because we make this world run electronically, right? So these are tools we can make use of, and look at the beauty of how we can turn around and make this very efficient. I hope you found that useful. That's all I have. Thank you.